Good morning, beloved student. Edo, your tutor, is here with you this very beautiful Saturday to take you through your 2018 assignment, Computer Study 1, strictly for the DES, please. Strictly for the DES. You know, we have computer studies for the ACAs. This is computer studies for the DES, please. Please take note of that. Diploma in Secondary Education. For those taking diploma in secondary education, Computer Studies Module 1, because there are two, it's broken down into two modules. So this presentation only takes care of Module 1, Computer Studies 1, DES. Okay, let's set the ball rolling. Have you received your assignment? Yes, I guess. Have you started doing your assignment? Yes, I guess. Are you facing some problem? Yes, I guess. So what is Mr. Edo here for you? Today, I'm here to guide you through. So I'm going to be the driver. You sit down and have a cup of tea while I take you through the journey. And what are we going to look at today? As an assignment-based conduct class, let us have a look at your assignment and guide you. As I always say in every of my presentation, I cannot go through all the questions in your assignment. What I do is I pick out those ones that I think that are kind of complicated or a little bit require critical thinking, then guide you on how to go about it. Okay, my beloved student, what next? The assignment that is with you for Computer Study 1 has 9 questions, and you are expected to answer all the questions. The assignment prepares you for 2018 examination. See, what does that imply? It implies that if you don't get involved in the examination, in the assignment, you will have problems in your examination. Because if you give your assignment to somebody to do for you, remember, that person will not come to the examination hall. So do your assignment yourself. Okay? In my presentation today, I'm going to focus on the logic gates. The logic gate, which you have in your assignments. I think 1 or 2 or 3 of the questions. Logic gate. Now the logic gate is an elementary building block of a digital circuit. We are going to limit our discussion to 2 input logic gates. So what are the things we are going to focus on? We are going to focus on the gate and the truth table. What are those gates we are going to look at? The first gate that we are going to look at is the AND gate. The first gate we are going to look at is the AND gate. And on the screen is the AND gates. You must know how to draw the diagram of the gate. You must know, again, the truth table for each of these gates. Let us look at the AND gate. What the AND gate truth table looks like. And as I said, my discussion is based on 2 inputs. So the AND gate strictly straight. In a way you talk about a gate, we have 1 and 0. At times you have low and high, off and on. Alright? In the AND gate, the principle of the AND gate states that it is only when, I repeat, it is only when your input, all your input are 1s or they are high, that is only when the output can be 1 or high. Take for example, if I have 2 inputs, A and B, if I have 2 inputs, A and B, only when A is 1 and when B is 1, that is when the output can be 1. All the input must be 1, 1, then the output can be 1. That is the principle of the AND gate. Let us look at another gate, the OR gate. the OR gate. The OR gate is built on the principle of either or, this or, buy me kapana or matagara. Can you see now? But I prefer kapana anyway. That is joke by the way. So or, so either this can be there, all this either can be accepted. So what is Mr. Edo trying to say about the OR? In the OR gate, this is the diagram of the OR gate. And the truth table of the OR gate states that if at least, I repeat, if at least one of the input is 1, the output will be 1. It is only when the two inputs are 0, 0, that is when the output will be 0. But if at least 1 is 1, the output will be 1. That is why you see on the screen 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 1. At least one of the input must be 1, then the output will be 1. Otherwise, if it is 0, 0, it's going to be 0. The next gate is the NOT. My beloved student, NOT gate is the most easiest gate you can talk about. Seriously speaking, the NOT gate is the most easiest gate. Why did I say so? The reason is that it has only one input and one output. And why am I saying that again, that is easy? It negates, it reverses it. So if the input is 1, the output is 0. If the input is 0, the output is 1. Shikena. Very easy as itikapana. Very easy, the NOT gates. We have another gate in your module which is called the NAND. If you know the AND gate, you have no problem with the AND gate. Remember, I've told you about the AND gate. Now this one is NAND gate. Look at the picture, the diagram of the NAND gate. Can you see is similar to the AND gate? The only thing that differentiates it is this NOT here. This zero here. Can you see? Otherwise, it's the same. So, as I said, if you understand the AND gate, you understand the NAND gates. It's just the opposite. And what did I say about the AND gate? In the AND gate, I told you when the input is 1, 1, the output is what? 1. Now reverse it. When the input is 1, 1, in the NAND gate, the output is 0. Now look at your NAND gate truth table. When the input is 1, 1, what do you have? The output is 0. But in the end, it becomes 1. Can you say it's just the opposite of the, what do you call it, the NAND gate? In addition to that, you have also the NOR. The NOR is also more or less also the opposite of the OR. It's just the opposite of the OR. Look at the truth table. The same thing. When it is 0, 0 in the OR, what do you have? 0. But in the NOR, when it is 0, 0, what do you have? 1. It's just the opposite. So for you to understand the gate is very easy. What are the gates we're talking about here? We're talking about the AND, the OR, the NAND, the NOR. Understand the AND, you understand the NAND. Just the opposite. Understand the OR, you understand the NOR. Just the opposite. And as I told you, the easiest one here is the NOT, which negate. So in summary, for every gate, you must know how to draw the diagram. For every gate, you must know the truth table. Let us take one example. It says, complete the truth table for the following logic circuits. Here I give you a gate. How do you complete this truth table? Here is the table. How do you complete it? Here is which gate is it? Can you identify this gate? This is AND gate. Can you identify this gate? This is NOT gate. Can you identify this gate? This is OR gate. Now, after you identify each of these gates, what is expected is you must remember their truth table, because the truth table will guide you on how to answer the question. Now let us look at the solution. Let me tell you how I got this solution. Pay attention very well. You see, I have two inputs here. I always say our inputs at this level is restricted to 2. So my input is A and B. Can you see? Input is what goes in. Output is what comes out. So my output is X. My input is A and B. So in binary, we always have, so we have 1 1 0 0, 1 0 1 1. So for your input, anytime you have an input, please, you always have this. Anytime there's an input, please bear this at the back of your mind. Anytime you have an input, you have 1 1 0 0. The next one will be 1 0 1 0. Very easy. If it's 2 input, I'm not going to talk about 4 input here. I'm limiting it to the model. 1 1 0 0. The next one will be 1 0 1 0. Very easy. Then that is the inputs. That's what you have in A and B. Those ones, you should know them, and they will always be used. Okay? Now, let's look at it now. This is A. Look at the way I'm going to solve it. This is A. A is coming inside the... Which gate is this? AND gate. And what else came inside the gate? Can you see? There's a line here coming inside the gate. This line is for B also. Meaning here is also B, because it's telling you where the line came from. So it means A and B comes inside the gate to produce C. The output of A and B is C. Now, in the AND gate, when you have A and B, can you see, if you look at the truth table here, if you have A and B to produce C, what is the truth table of AND? Can you remember? Let me take you back a little bit to AND. I want you to look at the truth table of AND so that it will make sense to you. In the truth table of AND, when it is 0 0 0, 0 1 0, 1 0 0, 1 1 1, only when both of them are 1 1 that you have 1. So you are going to use the same principle to answer the question. Now, 1 1 1, 1 0 0, 0 1 0, 0 0 0. Only when I have 1 1, I have 1 here, because A and B comes inside this gate to produce C. That is why I got this C here. Now this is D. The D is an output of B. Can you see? D is an output of B. Meaning whatever comes out in B, the output will be D. And which gate is this? This is NOT gate. NOT. And NOT gate is the easiest gate, which I told you, whatever comes in is the opposite you get. So if it is 1 that comes in, the output will be 0. If it is 0 that comes in, the output will be 1. So let's look at B. This is B. Producing what now? D. So if 1 comes in, then D, the output will be 0. If 0 comes in, the output will be 1. If 1 comes in, the output will be 0. If 0 comes in, the output will be 1. That is how we got D. Finally, C and B enters a gate called what? OR. C and B enters a gate called OR to produce X. And don't forget the principle of OR. Either can produce 1. At least if one of the input is 1, the output will be 1. And what are the two inputs going inside? It is C and D. C and D to produce X. So 1, 1, 1. 0, 1, 1. It's only when you have 0, 0 that you have 0. That is how we got this X. So things that can help you here is, number 1, you must know the gate. You must know the truth table. Can you see it is easy, my beloved students? It's easy. All you need to do is to practice it. Practice it. Practice and practice and practice. You will get it right. About the gates. Then in your assignment again, in Module 1, Computer Studies for the Diploma in this Education Senior Secondary School, there are issues I put there, some questions that has to do with sensor. What is a sensor? You need to understand what a sensor is. A sensor converts a real-world property into data. A sensor is a device that converts a real-world property into data. It means that a sensor, it responds to an external environmental condition. What does it mean? Let me give you one practical example. There are offices that if you are about to enter those offices, as you step closer to the door, what does the door do? The door opens. Nobody opens it. How does the door know that a human being is coming and the door must open? There is a sensor. So the sensor is responding to an environmental condition. There are these lights, security lights. If it gets close to those security lights, what happens? The light illuminates. If you go far away from the light goes off. How does the light know? There is a sensor that senses a human being. So a sensor responds to an environmental condition. And what are those environmental conditions? It can be heat. It can be pressure. It can be light. It can be movement of a human being. That is why when you boil your water in the kettle, after the kettle boils at 100 degrees Celsius, what happens? The kettle tricks off. Who tells the kettle to tricks off after boiling at 100 degrees Celsius? There is a sensor that senses it is already at 100 degrees, then it tricks off. So a sensor is a device that responds to environmental condition, thereby converting the data to the computer for processing. And what are those environmental conditions? The next slide tells you about temperature, light, pressure, moisture, water level. That is why in your washing machine, when the automatic washing machine pumps water into the washing machine, it gets to a level, it stops pumping. Who tells the machine to stop? The sensor already senses that this is the highest level, then it stops pumping. It responds accordingly. So we have different types of sensors and what they do. You must study it, know what a sensor is and how it works. Apart from the issue of sensor and gates in your assignment also, in section B is a practical section. Section B is a practical section. Question A precisely, I ask you to design a website for me. Yes, it's there in your course module. To design a website using the HTML. Use the HTML software to design web pages. You know, the web pages will be combined to form a website. So I read it again. Use the HTML software to design web pages. Your web pages should be minimum of 3 web pages. Design for me minimum of 3 web pages. And what type of web pages will you design for me? The first page should be all about a page where customer can make an order. Another page where customer can search for information about the product you are selling. Another page can take care of how customer can make payment. So I want a website that if I log into your website, I can search for the product you are selling, select a product, and make a payment. Link your pages together. It's very easy to design a website nowadays using the HTML software. Design it. Test it. How are you going to submit it for me? Submit the soft copy to me. Don't print it. Submit to me the soft copy of the website to me. I will test the site myself. You don't need to host it. No, there's no need for you to host it. No, there's no need. You don't want to host it. It's just for academics purpose for now. So design a website. As I've said, based on what I said, if you look at my assignment, I said the first page should contain the history of the organization and the director's profile. The second web page should contain the organization product list and the prices, and should be able to accept payment using the internet banking. Your third page of your design should contain the contact details of the organization. All the pages should be linked to one another. Test your website and see if it is working. But as I said, there's no need of you to host it. Just send the soft copy to me, to your memory stick. Be guaranteed your memory stick will be returned to you after marking and moderation of your work. So these are brief things in your assignment. This assignment is kind of short, but it's really practical oriented, because you are going to design a website and you are going to write a computer program. I've discussed the issue of computer program already in one of my presentations today, so I'm not going to discuss it here again. But your question 9 is another practical work. There you write a program for me. And what is your program going to do? The question is there. An estate agent advertises houses for sale. The customer wants to have the right to find out which house is available for sale anytime they log in. So write a computer program that can, number one, input the number of customers inquiries each day. How many customers check today? The computer program should be able to do that for me. The computer program should be able to tell me the prices. So write a program that will be able to do all these things that are listed in your assignment. You can use any programming language, but the program should be able to address these issues. Please test your program before you submit it to me. I need the soft copy. Don't submit the hard copy to me. I want to also test it. Run your program with normal data, abnormal data. Then submit the source code to me. So in this assignment, you are going to submit a memory stick to me. In that memory stick, there's going to be your computer, website design, and the program. Okay? This is going to be challenging. I want to build computer teachers that can teach my children in the future. I don't want to build computer teacher that will only be teaching my students how to play games in the computer lab. So you must do this thing. I'm grooming you, preparing you for challenges ahead of you as a computer teacher at secondary school. So don't say, Mr. Aido, why all these things? Remember, I'm building you according to the model. So don't give it out to people to do for you. You can consult, no problem, but involved so that you can be able to write programs, you'll be able to design websites at computer studies teachers. If you have further problems on this assignment, please don't fail to contact me. My number remains the same as 081 480 409. Edo is my name, your tutor for Computer Studies 1. I will present to you next time Computer Studies 2. Have a blessed day.